am NMCN. We are going to see the working and principle of transformer. Transformer is basically one of the most efficient machines or devices designed by man. The reason we will see at the end of the discussion. Transformer is a device which converts or transforms, as the name suggests, low voltage high current AC to high voltage low current AC or vice versa. This works only in AC circuits where current is changing. It won't work in a DC circuit because in DC circuit current is steady and induction won't take place. In simple form, it is based on the principle of mutual induction. In simple form, it consists of two coils which are electrically insulated from each other, wound on a closed ferromagnetic core such as soft iron. The core must be of high permeability and low retentivity. High permeability means the material or the core must conduct maximum magnetic field from the primary section to the secondary section. A low retentivity means it will not retain the magnetism it acquired for a long time. That is an essential requirement for the functioning of transformer. The number of turns of the primary coil, let it be NP, number of turns of the primary. The coil to which the AC to be transformed is delivered, is given, or is impressed, is known as primary coil, and the coil from which the transformed AC is delivered is called secondary coil. Total number of turns of the primary, let it be NP. Total number of turns of the secondary, NS. Now, as AC flows through the primary coil, AC being fluctuating one or since its strength and magnitude change periodically, this change will create a changing magnetic field inside the primary. This changing field will pass to the secondary through the core being of high permeability. Then mutually induced EMF will develop in the secondary, depending on the permeability and other factors of the core and the coils. Then let phi be the magnetic flux linkage per turn of the primary. Flux linkage, these things I have discussed earlier. You must see the earlier postings. For that you must subscribe the channel, otherwise you can't get the previous postings. Now let phi be the number of flux linkage, magnetic flux linkage per turn of the primary coil. Then the total flux linkage of the primary will be phi into NP. If there is no flux leakage, that is the entire flux associated with or generated in the primary section is passed to the secondary without any reduction, the total flux linkage of the secondary will be NS phi S, NS into phi. So total flux linkage of primary is NP into phi, and total flux linkage of the secondary will be NS into phi. If there is no flux leakage, that is the entire flux associated with the primary is passed to the secondary without any reduction. Since these two fluxes are changing because we are supplying AC, Then the induced EMF in the primary Vp according to the Faraday's law is minus d phi p by dt. That is minus d by dt of phi p is np into phi. You can take np outside the differential, so it is minus np into d phi by dt. Mutual induced EMF in the secondary Vs equals d phi s by dt equals minus ns into d phi by dt. Just you divide these two equations, then you get Vs by Vp equals ns by np. Since ns and np are constants, this ratio is also a constant, or Vs by Vp is a constant for a particular transformer. Now, what about the power associated with transformer function? Input power is input voltage into input current. Voltage into current gives you power. So, power input is Vpip. Output power is Vsis. If there is no power loss, that is, the transformer is perfectly ideal without any defect, you can equate the two power values giving Vp/Ip input power equals output power, or Vs by Vp equals Ip by Is. In a step-up transformer, Vs is greater than Vp. If Vs is greater than Vp, then Ip must be greater than Is, or Is must be less than Ip. So a step-up transformer of voltage must act as a step-down transformer for current. And in a step-down transformer, Vs is less than Vp. So that Ip is less than Is, or Is is greater. So a step-up transformer of voltage must be a step-down transformer of current, and vice versa. Now, efficiency. Even though now transformer is generally highly efficient because there are no moving parts in a transformer. Wherever there are moving parts, energy loss due to friction is a reality. We can't avoid friction if there is motion, relative motion between two parts. Here there are no moving parts. It is a mute worker transformer. So efficiency is as high as possible. Still, our efficiency is defined as always, eta equals output power by input power. It is Vs by Vp Ip. If the transformer is ideal or perfect, eta must be equal to 1 because Vp Ip equals Vs, then eta equals 1. But in real transformer, case of real transformer, there are certain power losses. There are three major power losses. One is called Joule loss. The two coils are wound using metal wires, copper, aluminium, etc. These metal wires have their own resistance, ohmic resistance. So when current passes through them, they will heat up. Heat is always a wastage of energy, I squared R loss. This is called Joule loss. The coil will heat up when the transformer works. The other one is eddy current loss. We will discuss eddy currents, hysteresis, etc. when we come to magnetic properties of materials. When a magnetic material or a conducting body is placed, not necessarily magnetic material, when any material body is placed in a changing magnetic field, induced currents in the form of small loops will develop within the body of the material. Such currents are called eddy currents or Foucault currents. These currents are responsible for heating the metal body. So here, since the current is changing, Changing magnetic field are set up in the core, and eddy currents will develop within inside the core, and the core itself will heat up. And that is a wastage of energy. Such power losses are called eddy current loss. You can minimize it by using certain materials and using laminated sheets separated by insulating materials. We will discuss all these things in QMaster postings. Then finally there is hysteresis loss. Whenever a material is magnetized and demagnetized repeatedly, a certain amount of energy will be lost by in the form of heat. That is known as hysteresis loss or hysteresis effect. You can reduce it by choosing proper materials such as soft iron, etc. And we will discuss this hysteresis loss in the section magnetic properties of materials in detail. Uh, there is still yet another power loss that is called loss of the efficiency. There's another factor reducing efficiency, that is leakage of magnetic flux. The entire flux associated with the primary may not appear in the secondary. There may be a loss of flux due to several reasons, and that is reduced by properly constructing the core in proper shapes and so on. That's not at all important here. The major power losses are these three: Joule loss, eddy current loss, and hysteresis loss. Okay, of course you can mention power loss due to flux leakage also. We will discuss more details in coming postings about transformer. Thank you.